In this video, we're describing the cards module, which is a Python module that supports dealing playing cards. So what you see here is the standard 52 card deck of playing cards. And so you can see they're arrayed here from the upper left, two of spades, to the lower right, ace of diamonds. And you can see that there are 52 unique cards in our deck. So to start, we're going to represent our 52 card deck simply by, let me jump in Python here, as a list of 52 unique numbers. So we can just call our deck range 52. And so now we have these 52 unique numbers, 0 through 51, that we'll use to represent our deck of playing cards. And so if I want to deal a random, say, 5-card hand from our deck, we can use the random module, import random, and we can just say random sample deck 5. And there's a random 5-card hand. There's another random 5-card hand, and so on. And so actually representing the unique cards is relatively easy, and then dealing from those cards is also relatively easy. Of course, when you look at this hand, 46, 12, 44, 28, 18 is a little bit different than what we see here in the playing card deck. And that's because while we have 52 unique cards, what we really have, the uniqueness of any one card is created by two separate attributes. We have a card and we have a suit. And so we have the cards that go from 2 to the ace. So 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. And then we have 4 suits, spades, hearts, clubs, diamond. And so those two attributes together are what creates the uniqueness of each one of our playing cards. So in order to use my representation, so here's my representation here of our deck, you can see, I need to be able to convert, or I need to be able to interpret the attributes from the unique number. So for example, back to my hand here where I have 46, 12, 48, 18, I need to know when I deal this 46, what's the card and what's the suit. Similarly, when I deal this 10 on the second hand, I need to know from that number 10, that unique number 10, what's the card and what's the suit in order to be able to play any meaningful card games. So if we look at this deck of cards, what we can see is that we can divide the cards into these columns, which are for the individual suits. So we have spades, hearts, diamonds, clubs, and then the individual card, which is in the rows. So we have our ace, 2, 3, 4. Notice that I moved the ace from the top to the from the highest card to the lowest card here. So we're going to define our cards from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And then I'm going to define what I call a base, which relates a number to that individual card. And so in our terminology, a 0 corresponds to an ace, a 1 corresponds to a 2, a 2 a 3, and so on. When we get to our face cards, a 10 represents a jack, an 11 a queen, and a 12 a king. And so in this structure, here are our 52 unique numbers. And so if we pull back up the hands that we dealt, there we go, back to our original question of, well, we have to be able to interpret 46. If we look in this table, here's our 46 right here, and you can see, if I can scoop this over, it's in the club column, and all the way over here, this is the 8. So 46 corresponds to the 8 of clubs. Similarly, if I look at 28, where's my value 28? There's 28 right here. So 28 right here corresponds to the 3 of diamonds. And so if we have this representation, we can take any one of our 0 through 51 number, which we have right here, 0 and 51, and convert that using our table into the two attributes that we need, which is the card and the suit. And so we can do this if we just assume that x is an integer between 0 and 51 inclusive, 0 and 51. We can simply get the card using the mod function. So card equals x mod 13, and the suit, we can use the fact that Python does integer division and truncates. So we're going to get the suit by doing the spade, hearts, diamonds, clubs, string, x divided by 13. Because x is an integer, we know that x divided by 13 is either going to be 0, 1, 2, or 3. And so we will extract the corresponding suit, spade, heart, diamond, club, directly from the string using our integer arithmetic. Note, and this is really important with our representation here, when I say card here, what I'm really getting is the base. So if I have a value 0 and do the mod 13, then I return 0, and that represents the ace. And that's really important with our numeric cards between 2 and 10. So for example, if I do have the value 4, so if I have card number 4 and I do 4 mod 13, then I end up with the base of 4, and that represents the card 5. So we need to have that representation of the card for the particular game that we're going to play, but the base value will give us our unique values. So we go back to Python here. We can see that simply by, let's just enumerate through. So here's our deck, remember, deck. And so I'm just going to say for I in deck, print I mod 13, which is our base, and spade, heart, diamond, club, x13, which is our suit. Oops, x is not defined. Let's try that one more time for I in deck. Print I here. So I used x before, so I tried it there. And then we'll just print those values. And now we can see our 52 cards represented in the 2 attribute format, where we have 0 through 12 spades, 0 through 12 hearts, 0 through 12 diamonds, and 0 through 12 clubs. Note that the representation for our cards is still these integers between 0 and 51. So when we want to infer meaning from those values is when we go through and use the mod function in our string. So in order to apply this, what we're going to do is we're going to define a convert function. So we'll just define convert, and it's going to take a single parameter x, which is an integer between 0 and 51 inclusive, and define card is equal to x mod 13, and suit is equal to spades, hearts, diamonds, clubs, x divided by 13, and then we return card, oops, don't comma there, return card suit. So now we have a utility function that takes our representation and converts it to the 2 attributes card and suit. So we can say convert 46, and that's the 8 of clubs. Remember, 7 is the base, not the actual card, it's the base. So this would be the 8 of clubs. And convert 10 would be the jack of spades. So we go back here and say that 10 here is in fact the jack of spades. And what did I do? 46 here. What did I do? 46 was in fact the 8 of clubs with the base of 7. So we can define this convert function as a utility to convert our integer value, which is our actual representation of the cards, into the more meaningful values to support card game. So the representation as an integer between 0 and 51 and the corresponding convert function form the basis for the cards module, the Python module cards. You can see here's the convert function that we just talked about with 1 or 2 little additions here. These are 2 different stringify functions. So while the card and suit, or what we call the base and the suit, identify those two attributes, it's still not what we're used to seeing as people. What we're used to seeing as people is the more familiar ace of spades, two of spades, three of spades, or something like that. And so within the module, scroll down here to the bottom, I provided two string functions. The first one provides the long form, so ace of spades, ace of hearts, and so on. And the second one provides a more short form that creates a human readable string from the card. And so when you execute the convert from the cards module, you can see that you return the card and the suit just like we did before, in addition to these two string values. So if we go back in Python, let me just exit here to get a clean namespace, Python import cards. Now we have this function. Let's define our deck equals range 52. There's our deck. And now we can use cards, convert, let's say 34. And so what it returns are the two things that we defined before, which is the base and the suit, and then the two string functions, or string versions of that. The long form 9 of diamonds, and the short form 9D that we can use. And so the convert, again, in addition to providing the two attributes, also provides the other thing that we can make human readable form. So we could do something like for I in deck. Let's just print out the long form. So we could then just say cards, or print cards convert I, and then we want the 0, 1, 2th element, like that. And so now we can see as our array of cards, ace of spades to king of spades, ace of hearts to king of hearts, ace of diamonds to king of diamonds, ace of clubs to king of clubs. So we can see the meaningful human readable form. We can also do the short version. Let's see, I guess I have to do the whole for I in deck. This time let's do 3. And now we have the short form also. So now that we have our representation, it's just an integer between 0 and 51 inclusive. We have a way to convert to more meaningful card suit notation, and then now we can print those values in human readable form. Two additional utility functions in the module. One is called draw1, which lets us draw a random card from a deck. So you can see that we import the randint function here. We're just going to pick a random integer and return the converted value. So in our Python, we can simply say cards draw1, 1 with an E, and there's our card. And so we can simply cycle through here and draw as many random cards as we want. Note that this type of sampling, we're doing sampling with replacement. We're drawing one card, and when I draw the next card, I'm drawing it from a completely new deck. If you look at how we've structured the module, we're drawing a random sample of size 1, or a random integer between 0 and 51. So every time I do that, I'm drawing from a pristine or a complete deck. On the other hand, the draw_in function lets us sample in cards from a deck without replacement. And so let's, for a second, skip this second parameter in, m, which is number of decks, and say when we draw in, so if we do cards draw in 5, for example, we're sampling 5 cards without replacement from the deck. And so, for example, if I want to draw a 5-card poker hand and see it in human readable form, I could just say for card in cards draw in 5, print card 2. And our 5-card hand is a 2 of clubs, king of clubs, 9 of diamonds, queen of diamonds, 7 of diamonds. Similarly, using a comprehension, card 2 or card in cards draw in 5. So a comprehension will give us that a random 5-card hand, again in human readable form. If I want the short form, I want to do some processing, for example, there we go. I could also get the actual base value in the suit similarly. And finally, back to the M parameter, which is the number of decks in the shoe, and which you can see here in the function definition defaults to 1. And so that's why when we did draw in 5 and didn't specify an M parameter, we were simply sampling 5 cards from a single deck. If we want to sample from multiple decks, then we're simply going to use the fact, here's our deck of cards, that we can use the multiplication operator. So if I want to have, say, 2 decks, I can say shoe is equal to deck times 2, and then look at shoe, and you can see that we've simply replicated 0 to 51 and then 0 to 51, and so this would be the first deck and this would be the second deck. And so we use that method to allow the user to specify here using the M parameter. So for example, if I wanted to do the same thing that we did before, so I'm going to say, let's see, draw 5. This time let's make this a 3. Then what we're sampling from is 5 cards from 3 decks. So you randomize 3 decks of cards and you draw 5 of them. If I wanted to have a 6-deck shoe, I could simply send a 6 there, and we're randomizing 6 decks and drawing 5 values from those. Note that we can also use the draw in function to simulate dealing multiple hands. So if you were playing poker, let's say you're playing poker with 4 other people, so you need to deal 5 hands. So we could simply do cards, draw in, except this time instead of drawing 5, we're going to sample 25, and this would be a list of 25 cards. So the first 5 would be for person 1, the second 5 would be for person 2, and so on. You'd have to partition the list or use a slice or something like that to actually extract that information, but the draw in function is set so that you can sample in cards from M decks of cards without replacement, and that's in fact what you would do if you were dealing. So to summarize, the cards module allows us to take a representation, a very simple representation of a deck of cards, 0 to 51, integers 0 to 51 inclusive, convert that into a human readable or to a human interpretable form, which includes the card and the suit, and then print those in human readable form, and then draw random samples from that deck.